Welcome to This Explainer. The silicon architecture we take for granted today, the processors powering our phones, our laptops, basically our entire digital lives, they didn't just magically appear out of thin air. It's actually the result of thousands of years of relentless mechanical problem solving. So today, we're diving into the early history of computing devices to see how a handful of brilliant historical inventions laid the absolute groundwork for the powerful tech we rely on right now. So, how exactly did these early inventions shape the computers we use today? Well, to figure that out, we've got to look at our continuous, almost obsessive human drive to solve complex calculating problems. For thousands of years, we faced some pretty immense data challenges, whether it was for managing early trade routes, orchestrating massive construction projects, or pushing the boundaries of science. We desperately needed tools to help our brains process numbers. What we're exploring today isn't just some dusty list of old machines. It's the story of how humanity relentlessly sought out new ways to abstract and solve problems, step by step, century by century. Okay, let's dive right into this timeline. When you map this journey out, the most striking detail is just the sheer scale of time involved. We start way back in 3000 BC with the abacus. And then, the very next major leap brings us to 1617 with Napier's bones. That is a massive gap. We're talking over 4.5 millennia between the first big milestone and the second. But here's the crazy part. From there, the pace of innovation aggressively accelerates. We jump quickly to 1642 with the Pascaline, and then later on to Babbage's engines. Computing started at an incredibly slow crawl, but man, once those gears started turning, it picked up tremendous speed.
Just think about that starting point for a second. 3000 BC. Long before the Industrial Revolution, early civilizations engaged in complex trade and agriculture, and they desperately needed a way to offload mental math. We needed a system. We aren't talking about a few hundred years ago here. We are talking about 5,000 years ago. Ancient societies in places like Mesopotamia were already identifying this profound need to track inventory and taxes, and that direct need drove the invention of a dedicated computational tool.
And that exact ancient drive gave us the abacus. Invented around 3000 BC, it's widely recognized as the very first computing device. Now, moving beads along rods wasn't just simple counting. It was literally humanity's first successful attempt at abstracting data. By translating abstract numbers into a physical state you could manipulate, using positional notation, people could finally offload the sheer mental exhaustion of basic calculations. It was, in a way, our very first external hard drive for mathematical thought. But here's the catch. While the abacus still required the user to do a lot of the mental heavy lifting, that massive leap in 1617 changed the game entirely. Enter John Napier. He introduced a physical tool that used lattice multiplication, which fundamentally lowered the mental barrier to complex math. Napier's bones wasn't just a minor tweak, it elevated what humans were capable of doing. By simply aligning these inscribed rods, a user could pull off advanced multiplication and division way faster and with way fewer errors. It was an absolute game changer for mathematical processing power. Then, just a few decades later in 1642, Blaise Pascal created the Pascaline, which goes down in history as the first true mechanical calculator. This was a monumental paradigm shift for us. The Pascaline introduced this ingenious mechanical carry mechanism. For the very first time, when a gear completed a full rotation, it would automatically advance the next gear, fully automating addition. Before this moment, tools were just human-powered aids where you still had to remember to carry over your digits. The Pascaline gave us the birth of true machine-driven computation. Now, as we transition into the next great era of automation, we meet Charles Babbage. He designed two highly specific, unbelievably complex machines, the difference engine and the analytical engine. Babbage's ambition absolutely skyrocketed way past building a simple calculator. He wanted complex programmable machines. And you know what's truly fascinating here? These designs were so incredibly advanced that the engineering capabilities and metallurgy of the Victorian era couldn't actually manufacture the parts with enough precision to fully build them while he was alive. His vision literally outpaced the physical reality of the 19th century. But even though his machines remained mostly theoretical back then, the concepts within Babbage's engines became the absolute bedrock of modern computers. Think about it. A Victorian inventor literally mapped out modern computer architecture on paper. His designs included a store, which functions exactly like modern computer memory, and a mill, which acted as a central processing unit. The whole idea of inputting data, processing it mechanically in the mill, holding it in the store, and then outputting a result, that is the exact same blueprint supporting the incredibly powerful
digital devices we use today.
When we look back at this journey, we can clearly trace a distinct evolutionary DNA. We evolved from manual abstraction with the abacus to automated mechanics with the Pascaline, all the way to the brilliant theoretical architecture of Babbage's engines. Every single device you use right now, your smartphone, your tablet, your smartwatch, shares a direct lineage with these exact stepping stones. These early inventors laid the theoretical and mechanical groundwork that quite literally shaped the computers running our entire world today. Which leaves us with one final incredibly exciting thought to ponder. If a simple beaded abacus from 3000 BC eventually paved the way to the supercomputers of today, what on earth will today's computers lead to tomorrow?